So we'll insert a Watson-Fitourian introduction at the beginning, and then we should decide how much we want to talk about our retention model, and then we will go into the retention data set. Let's take a look at the retention data set that I've uploaded into Watson Analytics. This is just a subset of the data in our retention model. Our model contains many measures which let you see things like how many terms a student attended, his GPA, what degree he ultimately got, how many units he had by term, and really gives you a whole picture of the student's career. So this data that we're seeing here has just some of the attributes of students that we track, like gender, admit type, program and plan, whether they're full or part-time, what their SAT scores are, what their GPA for their first term was, their age, athletic and Greek participation, and others, and then indicates whether or not they graduated. I've brought this data into Watson Analytics, and I'm going to create a new analysis. So I've selected the prediction module. And first it's going to ask me to name my analysis and create a target that I want to predict. So I want to predict whether the student graduated or not. So it's going to look through all of the data and try to figure out which of the attributes of students tend to predict whether the student is likely to graduate or not. Obviously, we'll cut out some of this. So first, it defaults to looking at one field at a time, which we can see over here on the left. If I look at the target, which is graduated, I see that the factors closest to the middle are the most predictive, and then the detail is going to be over here on the right. So here I can see that average loan debt is a predictor of graduation with 81.4% predictive strength. And then over here on the right, I can actually look at the detail on that. So I can see how my different loan debt amounts for students map to whether the student graduated or not. So the statistical details here actually show me the actual calculations that are being used. And then if I click on details, I can see this as a stacked percentage chart, which may be a little bit easier to see. So here I can see that in general, loan debt doesn't seem to predict too much until we get to fairly large amounts, over $29,000, where suddenly the probability of graduating drops to under 10%. I can also see other single factors that drive graduation, such as the student's GPA. So here we can see that over 3.25 GPA, most of the students graduate, whereas that goes down a bit as we get down into lower GPAs. Now let's look at what happens if we go into two-field predictions. So as we might expect, since we saw that both average loan debt and GPA were driving graduation, the combination of those two has an even larger predictive strength. So here we can look at the different combinations of GPA and average loan debt. I actually find the details tab a bit easier to use. So this is showing us the relative percentages of graduated and not graduated for the different combinations of loan debt and GPA. So here we can see how does it decide how to group the GPA and the loan debt. and it's using equal frequency binning, meaning it's putting the same number of students into each group. So let's look at what other links it found. It also found that average loan debt and intended degree drive whether the student graduated. Again, I'm going to look here at the Details tab so I can see what my graduation rates look like for various combinations of those two factors. So I can click on any one to see how many records make that up. For example, here, my Bachelor of Science in Environmental Studies with the median loan debt only has 2 students in it. So although neither of them graduated, that's probably not statistically significant. This also tells me whether there's an interaction effect. That is, does the combination of these two factors, is that greater than the individual effects? And in this case, it's not. And here, Watson Analytics provides lots of explanations of everything that it's telling you about. There's actually also more information that I can get across the top here. So the prediction module will tell me about any issues with data quality, which includes things like fields that have a lot of nulls. Or it will tell me which of my inputs were potentially useful. Inputs might not be useful if it doesn't find any relationship between them and your target, or if a given input, for example, has all the same value. It also will tell you which fields are associated with each other. So let's take a look here at some of my field associations. For example, work study and Greek participation seem to be strongly associated. You can see here that almost none of the students who are in the Greek system are participating in work study, and vice versa. And then here in Main Insight, I can actually see the total relative sizes of Greek versus non-Greek and work study versus non-work study, and then the sizes of the combinations of those two factors. And I could look at the same thing for other fields that are associated with each other. But let's see what my predictions look like for combinations of fields. So here, it's showing me a decisions tree that shows me that average loan debt and 9 other inputs are influencing graduation. So let's take a look here. So here, it's showing me a decision tree, and I can look at various branches of that tree. I actually find it easier to look at the decision rules. So here, we can see the combinations of which factors have the highest graduation rates. For example, this combination of loan debt, GPA, on and off campus, and athletics, 100% of those students with that combination of attributes graduated. I can also choose to look at the lowest percentages. So here, students with these particular combinations had none of them graduated. And then statistical details will tell me how many students make up those records that make up those combinations. Then the predictor importance shows us of all of the attributes that it was using for its predictions, which ones contribute the most to the likelihood of graduation. Still need some kind of conclusion here. I'm not quite sure what it is. Maybe the Watson guys have some ideas for how to conclude this. Thanks very much for watching. Join us for some of our other videos where we look at some of the other functionality from our Fatorian data warehouse and talk about the other ways to visualize and refine your data in IBM Watson Analytics. Thanks.